Now that we're done preparing the Iron Man geometry, we can just move on to creating another geometry container. Let's call this sparks. We'll dive inside. And the first thing we want to do is make sure that we get the hit points of the thunderbolts. Let's create a object merge. Let's first have a look at the thunderbolt main. And remember, we were scattering points on the surface to determine where the thunderbolt was going to hit on the surface of Iron Man. And this is what we want to get. Let's create a null here to make it easier for us to actually find this. Let's just say how hit, Control C, because we will have exactly the same thing on Thunderbolt head. Same thing, Control V, out hit. So here on the sparks, we'll get an object merge and we'll call this get hit main. Let's select Thunderbolt main. Not exactly this. So inside Thunderbolt main, we want the hit. And I'm gonna create a copy and call this hit head. And it's gonna be the same thing, but inside the Thunderbolt head, out hit. That's done. So now we can merge these two. And we will have our sources. These 2 points, which have normals. Now the idea is to use the normal as a direction for the velocity, so we'll convert this normal into a velocity using a point wrangle, PW. And we'll just write at V, it's going to be equal to my normal. Now I'm declaring that these are vectors, but I didn't need to because these are variable attributes that are recognized by Houdini. But if it's a good habit to create, because when you create your own attributes, it is important for you to declare what type of attribute it is, if it's a float, an integer, a vector, or wherever. Now let's say this is called convert n to v. And we'll finally create our pop network. Let's connect this. This will be our main source. And let's dive inside a pop network. Let me go back and hide these. So this is going to be our source, and we'll have to take care of a few things here. First, I'm going to disable the guide. We don't need to see the guide. And here on the emission type, we'll convert this, switch this to points. Okay, we will be emitting from points. Next, here on the birth, we want to, let's just start with 1,000 particles, and we'll adjust this. And the life expectancy, let's say it's pretty short, something like 0.1 with a variance of 0.1, maybe a bit more here, 0.15, 0.1. And let's see how this looks. Okay, we have our particles being emitted and dying. They're using the inherited velocity. Here on the attributes, if we go to inherit attributes, we're inheriting everything. We just need the velocity. So if you want to switch this to velocity, that's fine. And initial velocity, we don't just want to use the inherited velocity. We want to add to the inherited velocity. And here we'll be able to add some variance, let's say 3 by 3 by 3, so like that. And we should get a bit more of spreading all around. Okay, and this is something, this is a good starting point. Let's make sure we have some gravities, because the sparks are supposed to be coming out and falling down. So gravity force, let's put it here. We should reduce the intensity, because if you think about it, not only the sparks are really small, so the ratio from weight volume will tend to increase the air resistance, but they're also very hot, which will also kind of counterbalance the gravity a bit more. So we'll say this is -5 instead of -9.8. Okay, and these are our particles.